Hello. Hello. Good afternoon.
Good afternoon, sir.
Good afternoon. Okay. So we are meeting after a long time. Uh, Today, actually, I'm going to start a fourth unit, that is neural networks. But before that, let's have a little bit of quick recap of unit number 3, what we have seen. So before the in-semester exam, actually only 1 point was remaining from unit number 3. Otherwise, we have completed the whole unit. So we'll also revise that that point what is been remaining in unit number 3, and at the same time we are going to revise this unit number 3 so that we can get in touch with the points and the syllabus that we have been looking for. So let us start with unit number 3, little bit of revision, just a flashback about classification and regression. So classification is the task that requires machine learning algorithm that learns to assign a class labels to the example from the problem spam. And one of the best example is classifying the email as a spam and not spam. As the name suggests, classifier classifies the data into different parts or groups or classes. It is used to predict from which the data set the input data belongs to. So it is useful for prediction purpose. For example, if you are taking the data set of a squares of a cricketer in the past few matches along with the average strike rate, then we can classify whether he is in form or not in form. So basically there are 4 types of classification, and which is nothing but a binary, multi-class classification, a multi-label and imbalanced type of classification. But out of this, in your syllabus, we will be having a binary and multi-class classification. So it is nothing but the process of assigning a new input variable X to the class they most likely to belong, and based on the classification model as constructed from previously labeled training data. The data with labels is used to train the classifier so that it can perform well on the data without labels. So actually what we are doing is that we are training the classifier on a data which is not labeled, so that we can check it on a labeled data. So you can do it with the help of this by checking that. This process of continuous classification of previously known classes trains a machine. If the classes are discrete, it can be difficult to perform the classification task. Then this is the binary classification used to predict one or two classes, whereas multi-class classification is used to predict more than two classes. Example of binary classification is email spam detection, churn prediction, conversion prediction. And the most important is that it can be also useful in the medical diagnosis applications, like detecting cancer or not detecting the cancer. And the best example of binary is again detecting spam or not spam in the mail. So the binary classification is nothing but the class for the normal state is assigned to class label 0, and the class with abnormal state will be assigned to class label 1. So normal and abnormal means if it is a lungs, the normal lung, if it is a normal lung or properly functioning lung, we say that to be as a class label 0, whereas it is having some kind of abnormal state, at that time it will belong to class label 1. Some of the popular algorithms that are useful for the binary classifications are logistic regression, KNN, decision tree, SVM, and naive Bayes. Some of the terms that are related with the binary classifications, that is for assessing the performance of the algorithm. One is a precision, that is nothing but precision is nothing but in a binary classification refers to the model's ability to correctly interpret positive observation. In the other word, how often does a positive value forecast turn to be correct? This is called as the precision. Then we have a recall. So the recall is also known as a sensitivity. So in binary classification, recall is used to measure how sensitive the classifier is for detecting the positive cases. F1 score can be thought of a weighted average of precision and recall, the best value being 1 and the worst value being 0. Now, in case of multi-class classification, we have a different number of examples that can be used here. It doesn't restrict itself to any number of classes. And the examples are classification of news in different categories, classifying books according to the subject, classifying students according to their streams. This is the example through a diagram which one can understand what is the binary classification and multi-class classification. So you can see that binary has only two classes, and whereas the multi-class classification is having in this example three classes. So more than two classes is nothing but multi-class, or more than one class, two classes, that is nothing but binary. So we can say that the classes can be just positive or negative, that is nothing but binary class. And we can say that the classes could be a sadness, happiness, disgusting, depressed. So various types of classes, that is called as the problem of multi-class classification. So we have also seen the differences between binary and multi-class classification based on the parameter of number of classes, algorithm used, and the examples. Then for assessing the classification problems, we have been using different performance metrics like accuracy, confusion matrix, precision, recall, F1 square, ROC, AUC, and log loss. So accuracy is a simple ratio between number of correctly classified points to the total number of points. But it has also some disadvantages. That is, if the data set is highly imbalanced, then the result may go into a wrong decision. From accuracy, the probability of the prediction model can be derived. So from accuracy, we cannot measure how good the prediction of the model is. This is the confusion matrix. So confusion matrix is a summary of a predicted results in a specified table layout that allows the visualization of the performance measure. So true positive, false positive, true negative, and false negative are the four conditions that can be calculated from the confusion matrix. So TP means true positive, FP means false positive, FN means false negative, and TN means true negative. So confusion matrix will get an appropriate example in real world problem like considering the diagnostic test that seeks whether to determine the person has certain diseases. So we can say that a false positive in this case occurs when person tests positive and does not actually have a disease, whereas a false negative occurs when the person tests negative and actually he is normal. For multi-class classification with C class labels, the confusion matrix could be C into C. Some of the advantages of confusion matrix is provides the detailed results of the classification. A derivatives of confusion matrix is widely used, and visual inspection of the results can be enhanced by using heat map. So this is how the assessing the classification problem. So precision is given by true positive upon true positive plus false positive. Recall is equal to true positive upon true positive plus false negative, whereas F1 square is twice the precision into recall divided by precision plus recall. So once you calculate precision and recall, we can calculate F1 square easily, as well as we can also calculate the accuracy also. So this is the precision, recall, and F1 square. Now there is a log loss which measures the performance of the classification model where the prediction of the probability is between 0 and 1. It increases as the predictive probability diverges from actual label. It is widely used metric of Kaggle computation. Example, log loss is given by -1 by n, summation I to n yi
Excuse
log
me,
of.
sir.
Uh,
So screen is not visible. It is showing that you are only sharing the screen, but actual screen is not visible.
एक मिनट. Now, hello.
No, sir.
No, just a moment. I'll stop the share and I'll go once again into the unit number 3. Now, could you see it? Still issue?
Yes, sir. It is showing that you are sharing the screen, but actual screen is not there, sir.
Okay. What is the problem? I have to see it. Now, same thing. I don't know what happened actually. Now it is clear. Now the screen is visible or still same thing?
Still same thing, sir.
Same thing. Okay. Okay. Just a moment. इसमें है ना शेयरिंग क्लिक मत करो उसमें सुनो ना Now is it visible?
No, sir.
नहीं है क्या प्रॉब्लम हो रहा है समझ में नहीं आ रहा। मैडम एक मिनट एक मिनट मैडम The log loss is a logarithmic loss that measures the performance of the classification model where the prediction is the probability value between 0 and 1. So if log loss increases, the predicted probability diverges from actual label. So that means the log loss has to be small. It should not have been more. So it could be given by log loss is equal to -1 by n summation of I1 to n yi log of pi plus y minus yi log of 1 minus pi, where n is the total number of data points in the data set, yi is the actual value, and pi is the probability of belonging to the positive class. Lower value of log loss is nothing but better for the prediction. So that is what the log loss is. ROC, it's a receiver operating characteristics curve, or ROC curve is created by plotting true positive against the false positive. So TP एक बार निकाल लिया तो against में उसको plot किया तो आपको ROC AUC मिल जाएगा. So in general, mostly AUC is having 0.5. That means it is no discrimination, whereas value between 0.5 and 0.7 is acceptable, and anything about 0.7 is good to go for a model. In most of the medical diagnosis, we find that AUC, if 0.95 is or more, is considered to be good for the model. Then the class probability estimation, we have seen one of the most efficient approaches to building a model that are sensitive to the non-uniform cost of error, and that is to estimate the class probability of the unseen instances and then to make the decision based on computing probabilities and log function. Example of the class probability engineering is considering a scenario where we have to detect a credit fraud. The manager of the fraud controls department wants to know not only who are likely to be fraud, but also the cases where credit risk is at stake. Here we must know that the class probability of the fraud for that particular case. The class probability estimation is nothing but the probability estimates to be well calibrated, meaning if you have 100 cases whose class membership probability is estimated to be 0.2, then about 20 of them are actually belonging to the class. Whereas the probability estimates to be discriminative, meaning that they should give different probability estimation for different examples. Say 0.5 as the class probability indicates 50% of the population is fraudulent. So this is how the class probability estimation means. Actually, you can estimate also how much fraud is done. It is not only about detecting the fraud or not only about detecting the spam and all those things, but it is also detecting how much percentage of the fraud or the spam detection has happened. So this is about the class probability estimation. Then we went for the regression. So it always consists of a set of machine learning algorithm methods that allow to predict continuous and continuous outcome variables based on the value of one or more multiple predictor variables. Briefly, the goal of regression model is to build a mathematical equation that defines y as the function of x variable. So there are three main matrices for the model evaluation and regression. One is an R square or adjusted R square. Second is a mean square or root mean square. And the third one is a mean absolute error. So the R square is given by 1 minus SS regression upon SS12 equal to 1 minus summation of yi minus y cap whole bracket square divided by summation of yi minus y cap whole bracket square. So this is how the R square, actually it is used to measure how much variability independent variable can be explained by the model. It is calculated by the sum of the squared of prediction error divided by total sum of square, which replaces the calculated prediction with the mean. So R square value is between 0 to 1 and bigger value indicates a better fit between prediction and actual value. This is mean square error. So MSE is equal to 1 by n summation of yi minus y cap whole bracket square. So MSE is an absolute measure of the goodness of the fit. It is calculated by the sum of the square of prediction error, which is real output minus predicted output, and then divided by number of data points. The RMSE is a root mean square is nothing but the square root of MSE. Secondly, we can also say that MSE is calculated by the square of error. Thus, the square root brings it back at the same level of prediction error and make it easier for the interpretation. This is mean absolute error, which is similar to MSE. However, instead of sum of square of error in MSE, MAE is taking the sum of absolute value of the error. So, जैसी absolute आता है, यहाँ पर आपको मॉड्यूल आ गया, देखो mod of yi minus y cap of I. That is the difference between MSE and MAE. Compared to MSE, MAE is more direct representation of sum of error terms. Then we have also seen the overfitting. Yes, the techniques to reduce overfitting, increasing the training data, reducing the model complexity, early stopping during the training phase, ridge regularization and lasso regularization, and use dropout for neural network to tackle the overfitting. Then we have also seen the case study of polynomial regression. Theory of generalization also we have seen. Hypothesis we have seen. Hypothesis in machine learning, that is two types of hypothesis, lowercase h hypothesis and uppercase h hypothesis. So the lowercase h hypothesis represents a given specific hypothesis, whereas the uppercase h hypothesis is being searched out. So this is how the is there. And these are the takeaway of the hypothesis in machine learning. Covers the available evidences, the training data set is falsible, then a task test harness is devised beforehand and used to estimate performance and compare it to the baseline model to see if the skillful or not. Can be used in new situations for making predictions on new data. Then we have also seen the growth function, bounding of the growth function. This was the point which was remaining there. So a little bit we'll see that this is called as VC, called as a Vapnik-Chervonenkis. So we can drive the upper bound of the growth function by improving the polynomial bond and then combining it with the help of VC dimension. The VC dimension is a single parameter that characterizes the growth function. The VC dimension of the hypothesis set H, denoted by DVC of H, is the largest value of M, then DVC of H is infinity. To illustrate this definition, we will take a second look of the example as far as the growth function to learn their VC dimension. Remember that VC dimension can be only understood by if you understand the growth function and the bounding of the growth function. So this is how the formulas are of the VC function. And this is the regularization theory, which we have already seen. Okay, so this was the somewhat a revision, or I could say that just a flashback of what we have seen in unit number 3. Now we'll move to unit number 4. Just to begin with unit number 4, we'll just go it, just a moment. So this is unit number 4, which we are going to start today. So after understanding unit number 3, unit number 4 is a little bit of small unit, not much of the complications, because we are concentrating only on one concept called as neural network. And some of the concepts you have already seen in artificial neural network. So that is what we have seen as ANN can be used. ANN is supervised as well as unsupervised machine learning algorithms. So in that we have seen what neural network is about. So you have actually basic idea about what the neural network is about. So now one by one we are going to see what is neuron, how this neuron works out, whether it is been working in the similar way as the network works in a brain. So how the neurons work out to be in brain is the similar concept of working of neural in the network. So does it mimic the same kind of function which the brain does, or does it have some kind of different workouts? So we will be seeing these things in neural network. So let us understand first this neural, from where it has come. It has come from neuron. So the neuron is the basic unit of the neural network. So how the neuron look like, you can see from the figure. There is a neuron which is having two inputs, x1 and x2, and there is one output, that is y. So as in brain also, you can see that there are different neurons which combines do some kind of functioning, and then you get a particular output. So if I'm thinking of something and I want to act it, if I'm thinking and I'm going to act it, that there will be some particular part of the brain where the neurons will be activated and they will do some kind of functioning, mathematical functioning, and the output will be delivered in such a way that the brain gives a command to act on it. So that depends on how you are going to work out on the neurons. So similar kind of functioning neural network does. So the neuron in that network is called as the neural network, which is nothing but the basic unit. It has an input and does some kind of maths with them, and then you can produce this one output. Here what a two input neuron looks like. So you can see that there is an x1, x2, two inputs, and there is an y as an output. Now, three things that happens with the neuron is, first one, the each input is multiplied by the weight. So if you go back a little bit, you can see that there is an x1 and x2. So first of all, the x1, here we can say that x1 is nothing but x1 into the weight 1. Now, what is the value of weight? You can just change it. You can give some specific value of the weight at initial stages, and you can see that how much error is there. If the error is less, then that means your weight value is good enough. If the error is more, by back propagation, you can go back again and change the value of weight. So the weight is nothing but actually the value which is in our hand, so that we can change the weight value and can reduce the losses. So obviously, initially you can take some values of weight. So x1, that is one input, will be multiplied by the weight to get x1. x2, when multiplied with the weight 2, that is w2, we'll get an x2. Now next, all these weighted inputs will be added together with a bias. So where will it happen? It will happen in that circle. You can see a blue circle there. So it will happen there. So what will happen is that x1 will be multiplied by w1 plus x2 will be multiplied by w2 plus one more parameter will be added called as a bias. Now, this bias is also very much similar kind to how you select weight, because if I'm having some kind of weight and if I'm going to change it, that means I'm having a little bit of hand in hand with myself to get an accurate result. Similarly, the bias is also is one of the parameter where we can change the value of bias to reduce the error. So w1, w2 and b, these are the some of the things which are in a hand to change it accordingly how much error you're getting in the output. So the weighted inputs are added together with a bias B. So you can see that x1 into W1 plus x2 into W2 plus B is nothing, the step number 2. Now the third step is that finally this sum is passed through an activation function. So now this sum is been calculated at this point, and then after this there will is an activation function. Now we'll see what these activation functions are. So what will be there, how this activation function will look like is y is equal to function, that is activation function of all the parameters that we have weighted together. So how it will act like y is equal to function of x1 into w1 plus x2 into w2 plus bias. So this is nothing but applying activation function. So first we are having two inputs, one output. The two inputs x1 and x2 will be multiplied with the weight w1 and w2. Then the weighted inputs will be added together with the bias. Then you're going to apply the function on this equation. So you're going to get a final output as y. So y is equal to f of x1 into w1 plus x2 into w2 plus b. So these are the three things that happens here, that is in the neural network. Now the activation function, that is the last stage. Now what is the last step? The third step is that you're passing the sum actually to the activation function. So what are the activation functions? How these activation functions work out is going to be a very important parameter that is to be understood. Now this activation function is of two types. Two types of functions can be used here. We have seen in artificial neural network, we have seen that how the epochs are used and which kind of function could be used. So in that we have seen that the first neural network, when we have applied the first stage, at that time we have used some kind of sigmoid function, and then in somewhere we have also used ReLU function. So now these activation functions are actually, there are two types of activation function that can be used with the neural network. Now what this activation function looks like, how they look like, and what are their main workout. So the activation function is used to turn an unbound input. Sorry. The activation function is to turn an unbound input into output that has a nice predictable form. So what is actually doing is unbounded input into an bounded output that has a nice and predictable form. ये काम है activation function का. A commonly used activation function is the sigmoid function, and second one is ReLU, called as a rectified linear activation function. There are some of the advantages and disadvantages of both these functions we are going to see in the next slide. But before that, I will say that the first function that is being here is a sigmoid function. Now this sigmoid function you have already seen in, I do feel so, in signals and system. We have seen these kind of signals, whereas this is the signal which is like a ramp. Whereas this signal is a sigmoid function, we have seen that it is given by SGN, something SGN sigmoid बोल के देखा था हमने. तो ये sigmoid functions जो है वो एक्टिवेशन फंक्शन बोल के यूज हो सकता है. और यहीं पे एक रेलू फंक्शन है that is called as the rectified linear activation function. So both this function looks like this. Both the functions can be checked out whether it should be applied to the first stage, second stage, or the input stage, then the hidden stage, and then the output stage. So depending upon the applications you can choose. But is there any kind of differences between these two functions to be applied? We are going to see in this slide. So you can see this slide. In a neural network, the activation function is responsible for transforming the summed weighted input from the node to the activation of the node or output from that input. So this is what the actually activation function does. ये सीधा सीधा ट्रांसफॉर्म करता है आपके वेटेड इनपुट को फ्रॉम नोड टू द एक्टिवेशन ऑफ द नोड. The sigmoid and hyperbolic tangent activation functions cannot be used in the network with many layers due to vanishing gradient problem. अगर बहुत सारे हिडन लेयर्स होंगे, क्योंकि हिडन लेयर्स तो आप जानते हैं ना, इनपुट लेयर होता है, आउटपुट लेयर होता है, और बीच में बहुत सारे हिडन लेयर्स आप रख सकते हैं. अगर बहुत सारे हिडन लेयर्स रहेंगे तो उस वक्त सिग्मोइड फंक्शंस और हाइपरबोलिक टैंजेंट एक्टिवेशन फंक्शंस they cannot be used because of the larger number of the hidden structures. And the reason is that due to vanishing gradient problem. Whereas in case of rectified linear activation function, it overcomes this vanishing gradient problem, and that allows the model to learn faster and perform better. Hence, ReLU is also used in much of the applications where you have large number of hidden layers between input and output layer. The rectified linear activation is a default activation when developing multi-layer perceptron and convolutional neural network. So ये तो दो applications में तो वो use होता ही होता है. In other applications also you can use. Although sigmoid can be used if you're having little lesser kind of hidden layers. Okay, मेरे ख्याल से यहाँ तक लेते हैं. एक्टिवेशन फंक्शंस को हम मैथमेटिकली कैसे करना है वो अगले लेक्चर में हम लेंगे. ओके, यस, हैव यू अंडरस्टूड?
Yes.
ओके, विल गो विद द अटेंडेंस. जस्ट अ मोमेंट. रोल नंबर 1.
Present, sir.
2.
Present, sir.
3.
Present, sir.
4.
Yes, sir.
5.
Present, sir.
6.
Yes, sir.
7.
Yes, sir.
8.
Yes, sir.
9.
Present, sir.
10.
Present, sir.
11.
Present, sir.
12.
Present, sir.
13. 14.
Present, sir.
15.
Present, sir.
16.
Present, sir.
17.
Yes, sir.
18.
Present, sir.
19. 20.
Present, sir.
21. 22. 23.
Present, sir.
24.
Present, sir.
25.
Present, sir.
26.
Present, sir.
27. 28. 29.
Present, sir.
28. Okay. 30. Okay.
Yes, sir.
Okay. 31.
Yes, sir.
32. 33.
Present, sir.
34.
Yes, sir.
35.
Present, sir.
36. 37.
Present.
38.
Present.
39.
Present.
40.
Present.
41.
Present, sir.
42.
Present, sir.
43. 44.
Yes, sir.
45.
Present, sir.
46. 47. 48.
Present.
49. 50. 51. 52.
52, sir.
53. 54.
Yes, sir.
55. 56. 57. 58. 59.
Yes, sir.
60.
Yes, sir.
61. 62. 63.
Yes, sir.
64.
Present.
65.
Present, sir.
66.
Yes, sir.
67.
Present, sir.
68.
Yes, sir.
69.
Yes, sir.
70.
Yes,
7,
sir.
Okay, 71, 72. Yes, any number missing out here?
36,
सर 61.
36 है, 61 क्या?
हाँ यस सर.
Okay. Next. Next. Okay, we'll go with the B. Roll number 1. Roll number 2.
Sir, present.
Okay. 1 and 2 both are present. 3,
Present, sir.
4,
Yes, sir.
5,
Present.
6,
Present.
7, 8, 9,
Present.
10,
Present.
11,
Present.
12, 13, 14,
Present.
15,
Present.
16,
Present.
17,
Present.
18,
Present.
19,
Present.
20,
Present.
21,
Yes, sir.
22,
Present, sir.
23,
Present.
24, 25,
Present.
26, 27,
Present.
28,
Present, sir.
29, 30,
Present.
31, 32,
Yes, sir.
33,
Present, sir.
34, 35,
Present.
36,
Present, sir.
37, 38,
Present.
39, 40,
Present, sir.
41, 42,
Present.
43, 44, 45,
Present sir.
46,
Present.
47,
Present, sir.
48, 49, 50,
Present.
51, 52, 53, 54, 55, 56, 57,
Yes, sir.
58, 59,
Present sir.
60, 61, 62, 63, 64,
Present, sir.
65, 66, 68,
Yes, sir.
69,
Present, sir.
70, 71, 72. Okay, any other number missing out here? B division? B division? No. Okay, so
Hello, sir. 63.
63 A division or B? Hello? A or B division? Okay. ठीक है. Okay, so we'll close here. Thank
Hello,
you.
sir.
हाँ,
B63.
B63. Okay.
Yes.
ठीक है लिखा है चलेगा. Okay. Okay, thank you all.